everyone, it's Mrs. Garple, and we are going to be looking at the first part of lesson 3.4, graphing lines in standard form. But before we get to that, let's take a look at horizontal and vertical lines. Horizontal lines. The thing about horizontal lines is that the y value of every single point along this line is going to be the same. So a horizontal line is going to have the equation y equals b. B is going to be some number, and that number is going to correspond to the y-intercept. Now the y-intercept is going to have the ordered pair 0b because on the y-axis, x is always 0. So wherever we're crossing the y-axis, that's the b value. A vertical line, no matter where we're at on this vertical line, the x value is always the same. So a vertical line is always going to have the equation x equals a, or x equals some number. That number corresponds to where it crosses the x-axis. So a is the value where we're crossing the x-axis. And the ordered pair for that point is a0, because every point on the x-axis has a y value of 0. Now, some things about horizontal and vertical lines. There's a mnemonic we can use to help us remember, and it's Hoivux. You might be, huh? But here we go. Hoivux. So H is horizontal. The O is actually for 0. So a horizontal line is going to have a slope of 0, and the y equals a number. So horizontal lines have 0 slope, and the equation is y equals a number. The vux part of that is a vertical line has an undefined slope, and the equation is x equals a number. And we'll focus on the slopes of these lines in a later section. But for now, what we really need to focus on is that a horizontal line is going to have the equation of y equals a number, and a vertical line is going to have the equation of x equals a number. So let's take a look at this. Here I have y equals -2. Well, if I have y equals -2, that means every single point on my line is going to have a value of -2 for its y value. So I can plot that on the y-axis, and I can find all kinds of other points that have a y value of -2. And as you can see, that's going to be a horizontal line. And then I can graph a horizontal line through those points. And because it is a line, I want to make sure to put arrows on the end, because lines continue on in each direction. For x equals 3, and I know that it's a line, that's telling me that every single point on that line is going to have an x value of 3. So I can start by finding 3 on the x-axis, and then plotting other points that have an x value of 3. And as you can see, every point that I plot is within a vertical line. So I can plot a vertical line through these points. And let's adjust this a little here, so that it's actually going through the points. There we go. And put arrows on each end because it is extending in each direction, vertically, or up and down. So here, I'd like you to try. And if you want to, you can change the scale, especially with the 2.5. Your scale doesn't have to always be by 1. So on a piece of paper, take some time and graph what these lines would look like. Y equals 2.5 and x equals -0.5. And now that you're back, let's see how you did. For y equals 2.5, I'm going to go ahead and change my scale so that we're going by 0.5 on my scale. So that I don't have to try to fit in between any lines. So that means 2.5 would fall right here, halfway between 2 and 3. And if I plot other points that have a y value of 2.5. I see it's going to give me a horizontal line. And I can graph through there. And then be sure to put an arrow on each end. For x equals -5, I'm going to just keep the scale of 1. -5 on the x-axis is 5 to the left. Other points that have an x value of -5 are above and below that point I plotted on the x-axis. So you can see they fall within a vertical line. And put arrows on, and we have our vertical line x equals -5. So now let's take a look at the standard form. Standard form is ax plus by equals c, where a, b, and c are real numbers, and a and b are both not 0. Because if one of them were 0, then we'd end up with either a vertical line or a horizontal line. So we don't want to have that. So in order to have a standard form, we need to have both x and y. And a could be 1. So in that case, you might just see x, or you might just see a y with no number in front of it, if b were 1, as long as we have real numbers. So ax plus by equals c, where a, b, and c are real numbers. The x-intercept is the x-coordinate of the point where a graph crosses the x-axis. It occurs when y equals 0. So when y is 0, we have the x-intercept. The y-intercept of a graph is the y-coordinate of the point where a graph crosses the y-axis, and it occurs when x equals 0. So 0b is going to be our y-intercept. And since we can graph any line with 2 points, if we can find the x-intercept and the y-intercept and plot those points on our graph, we can graph that line. So that's what we're going to be doing. We're going to find the x-intercept and the y-intercept of an equation, knowing that if y is 0, we have the x-intercept. If x is 0, we have the y-intercept. So let's take a look. Find the x-intercept by plugging in 0 for y and solve for x. So we have this equation, x plus 2y equals 6. And I'm going to find the x-intercept. So I'm just going to make a note here that I'm finding the x-intercept. And I'm plugging in 0 for y. So x plus 2 times 0 equals 6. Well, 2 times 0 is 0, so x equals 6. So the ordered pair of my x-intercept is 6, 0. And I can plot that point on my graph. 1, 2, 3, 4, 5, 6. There's my x-intercept. To find the y-intercept, we're going to plug in 0 for x. So y-intercept, 0 for x, so we have plus 2y equals 6. Well, if I have 0 plus 2y equals 6, I'm really just needing to solve 2y equals 6. And to solve that, we divide each side by 2. Y equals 3. So the ordered pair for my y-intercept is 0, 3. So I plot a point at 0, 3. I have my x-intercept, I have my y-intercept. I've plotted them on the same graph. And now I can draw a line through the 2 points. And of course, because it's a line, I need arrows on each end because it's going to extend in each direction. And there we have our line. So to find the x-intercept, plug 0 in for y and solve for x. To find the y-intercept, plug 0 in for x and solve for y. So here's your turn. Find the x-intercept and the y-intercept for each equation, and on your paper, sketch a line. Now that you've had a chance, let's see how you did. So I'm going to find my x-intercept. So that means I'm going to need to find what x is when y is 0. So 2x minus 0 equals 4. So I really have 2x equals 4. Divide both sides by 2, and I have x equals 2. So my x-intercept is the point 2, 0. Let's plot that point. The y-intercept, I need to find y when x is 0. So 2 times 0 minus y equals 4. Well, 2 times 0 is 0, so we have negative y equals 4. Divide each side by negative 1, and I have positive y equals negative 4. So that point is 0, negative 4. And then I can graph my line through my points. Place arrows on each end, and I have my line. Let's take a look at the second one. Starting with the x-intercept. Again, we're looking for x when y is 0. So 4 times 0 is 0, so we're left with 3x equals 24. Divide by 3, and x equals 8. So we have the point 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. Find the y-intercept. This time 0 replaces x. We solve for y. Well, 3 times 0 is 0, so we have 4y equals 24. Divide by 4. So y equals 6. So our y-intercept is at the point 0, 6. 1, 2, 3, 4, 5, 6. And let's graph our point. And make sure we put arrows on the end. And that is how we can graph lines using the x and the y-intercept.